Hello students, in previous lecture we have studied and solved the examples which is based on the different types of operations takes place on polynomials, that is addition of polynomials and subtraction of polynomials. We have solved the examples of addition of polynomials and subtraction of polynomials from practice set 3.2, from question number 1 to question number 3. Today we are going to discuss on the multiplication of polynomials. All of you have studied about the multiplication of monomial by monomial, monomial and binomial, trinomial or polynomial by monomial, and trinomial by binomial. And we have to solve the examples from practice set 3.2 of multiplication of polynomials as well as division of polynomials. Then first of all we will discuss on multiplication of polynomials. Then this concept is understanding by solving the few examples of that multiplication of polynomials. Then see here example, m square minus 5 into m square plus 2m minus 2. Then see here the first polynomial, that is binomial, while the second polynomial is a trinomial. Then we have to multiply that trinomial by binomial. Then there are two different methods of solving those multiplication examples, that is horizontal method as well as vertical methods. Then today we are going to solve the examples of multiplication by horizontal method. Then see here, first of all we have to multiply that second bracket, that is trinomial, by the first term. That means here the first term is here 1m square, which is multiplied to the second polynomial, that is 1m square plus 2m minus 2. Then here minus sign is there, therefore we have to write minus sign here, and then in second bracket we have to multiply that trinomial by that 5. Therefore here 5 into that trinomial 1m square plus 2m minus 2. Then first of all we have to solve those brackets separately. Then here now 1m square is a monomial, and here that bracket in which trinomial is there, therefore we can multiply that trinomial by monomial. That is, we have to multiply each term of trinomial by that 1m square. Therefore here we have to write that 1m square into 1m square. Then here plus sign is there, therefore 1m square is multiplied to 2m. Therefore here 1m square into 2m. Then minus sign is there, therefore 1m square is multiplied to 2. Therefore 1m square into 2. That is the first bracket in which we have to multiply the trinomial by monomial. Then similarly we have to solve the second bracket also. Then see here minus sign is there, therefore in second bracket we have to multiply that trinomial by that phi u. That means each term of that trinomial is multiplied by phi. Therefore, here phi u get multiplied with 1m square, plus sign is there. Then phi u is multiplied to 2m minus, then phi u into 2. Then see here, now at this stage every bracket in which monomial is multiplied by monomial, and then we can simplify this by multiplying or solving those all brackets. Then see here, 1m square into 1m square, that is 1 into 1, 1. M square into m square, that is m raised to 4. Plus here 1m square into 2m, therefore 1 into 2, that is 2. M square into m, that is m cube. Then minus sign is there, therefore 1 into 2, that is 2. M square, here variable is not there, therefore here 2m square. Similarly, we can solve or simplify the second bracket. Then see here, phi u into 1m square, that is phi u m square, plus here phi u into 2m, that is phi into 2, 10m, 10m. Then minus phi into 2, that is 10. Then see here, in the first bracket one of the polynomial, that is trinomial, is there, and here minus sign is there. That means we have to subtract the second polynomial from first polynomial. Therefore here outside the bracket minus sign is there, therefore we have to change the signs of each term in the second bracket by removing that bracket or solving that bracket. Therefore here first of all we have to write all terms of first polynomial as it is, 1m raised to 4 plus 2m cube minus 2m square. See here, minus sign is there outside the bracket, therefore here 5m square, of which sign is plus, therefore we have to write minus 5m square, plus 10m is there, therefore minus 10m is there. Then minus 10, we have to change the sign of that, plus 10. Then see here, there are few like terms are there. See here, 1m raised to 4, then that type of term is not there, therefore we have to write this term as it is, 1m raised to 4. Then cubic term is also 1 of there, therefore we have to write the second term as it is, 2m cube. But see here, minus 2m square minus 5m square, that means minus 2 minus 5, that is minus 7m square. Then minus 10m, that is a linear term, that is also only one term, therefore we have to write minus 10m. Then constant term, that is 10, plus 10 is there. Then that is the solution of that example, that is about the multiplication of polynomial. Then we have to solve the few examples of multiplication of polynomial from practice set 3.2. See here, in question number 4, the few polynomials are given here. Then here in question number 4, that see here, multiply the second polynomial by first polynomial, and here the example which is given, that is x raised to 5 minus 1 into x cube plus 2x square plus 2 is there. Then we have to multiply here again trinomial by binomial. Therefore, we have to multiply this second polynomial by x raised to 5 term. Then we have to multiply that second bracket with minus 1. Therefore, first of all, we have to write x raised to 5 into, see here, the second bracket, that is 1x cube plus 2x square plus 2. Then minus sign is there, therefore we have to write minus sign outside the bracket. Then remaining 1 is there, therefore we have to multiply the second polynomial, terms of second polynomial, by 1. Therefore x cube, that is 1x cube plus 2x square plus 2. Then here again we have to multiply each term of that second polynomial by x raised to 5. We can do that multiplication directly like that. See here, one coefficient is there, therefore 1 into 1, that is 1. X raised to 5 into x raised to 3, that is x raised to 8. When multiplication of x raised to 5 into x raised to 3 is taken, then base is same, therefore we have to write that variable. And here when multiplication with same base is there, then we have to add the indices of those. Then here we get x raised to 8. Therefore here we get 1x raised to 8 plus 2 into 1, 2, x raised to 5 into x square, that is x raised to 7, plus 2 into 1, 2, x raised to 5, that is x raised to 5. Then minus, we have to solve the same second bracket by the same method. Then 1 into 1, that is 1, x cube is there. Then see here that second bracket is multiplied by 1, therefore we can write the terms in the second bracket as it is, because every polynomial, for example x square minus 5, when it is multiplied by 1, then answer is x square by minus 5. The same polynomial is there, therefore here 1 into the whole polynomial that given here, that is 1x cube plus 2x square plus 2. Then see here we have to subtract the second polynomial from first. Therefore to simplify that bracket, 1x raised to 8 plus 2x raised to 7 plus 2x raised to 5. Then minus sign is outside the bracket, therefore we have to change the signs of all terms of the second polynomial. Therefore here plus sign is there, therefore we have to write minus 1x cube, plus sign is there, therefore minus 2x square minus 2 is there. Then see here, this type of term is not there, therefore we have to write 1x raised to 8 plus 2x raised to 7, 2x raised to 5 minus 1x cube minus 2x square minus 2. Then avoiding of writing coefficient 1 in those terms, there are few examples which is given in the question number 5, that is of division of polynomials. In previous standard, all of you have studied about the division of monomial by monomial, division of binomial by monomial, as well as division of trinomial by monomial. And here we are going to discuss or solving the examples of that division of trinomial by binomial. Therefore here division of polynomials. Then one of the example which is given here, that is 2x square plus 2, which is divided by x plus 2. Then see here 2x square plus 2, that is, let this polynomial p x. Therefore here 2x square plus 2. Then first of all, that 2x square plus 2, that polynomial should be written in index form. Therefore here 2x square, linear term is absent, therefore 0 x raised to 1 plus 2x raised to 0, or here 2x square plus 0x plus 2 is there, and that px is known as dividend. Then that polynomial is divided by x plus 2. Then here divisor is x plus 2. Then we have to find out quotient after division as well as remainder, not the remainder we get there. Then see here we have to solve that example. Then see here, first of all we have to write the dividend, that is in index form here. Therefore here 2x square plus 0x plus 2, which is divisible by x plus 2, that is divisor. X plus 2 is a divisor. Then how to solve this example? Then see here, first of all, taking the first term of the dividend, that is 2x square. Then here 2x square, which is divisible by x. Then that 2x square which have to divide it by x, that is the first term of that divisor, that is here 1x. Therefore 2x square upon 1x, that means here 2x into x upon 1 into x. Therefore we get cancelled, x get cancelled. Therefore here we get 2x upon 1 means 2x. Therefore 2x we written in the quotient, that is here 2x. Then see here we have to multiply that divisor, that is x plus 2 by that 2x. Then see here binomial, x plus 2 is binomial, which is multiplied by 2x, that is monomial. Then here we get 2x into x, that is 2x square, plus sign is there, 2 into 2x, that is 4x is there. Then here we get the polynomial that should have written below the terms, that is like terms of that dividend. Then see here 2x square, quadratic term is there, therefore that 2x square is written below that quadratic term 2x square, plus 4x is a linear term, and here 0x is a linear term, therefore plus 4x should be written below that 0x. Then see here we have to subtract that polynomial from these two terms. Then when we subtract the second polynomial from that first, then we have to change the signs of those. Here plus sign is there, therefore we have to change that to get minus sign is here. Here plus sign is there, therefore we have to change the signs of each term of that polynomials. Then see here 2x square minus 2x square, we get cancelled, therefore 0 here. Here 0x minus 4x, then see here 0x minus 4x, therefore 0 minus 4, we get minus 4, therefore minus 4x is there, minus 4x. Then the remaining term, that is constant term, which is taken here. Then minus 4x plus 2 is there. Then see here we can do the division up to the that stage when the remainder contains the term of which the degree of that variable is less than the degree of that variable in divisor. Then see here, the degree of that divisor is 1, and here also the degree of that minus 4x is 1. Therefore we can do the division further. Therefore again we have to write that minus 4x which is divided by 1x. Therefore here we get x get cancelled. Therefore here we get minus 4 upon 1 means minus 4. Then that minus 4 should be written in the quotient. Then again here we wrote the minus 4 here. Therefore minus 4 is multiplied by x plus 2, that is divisor, is multiplied by minus 4. Therefore here we get minus 4 into x, minus 4x. Then minus 4 into plus 2, that is minus 8. Then those terms which is written below the like terms. Then see here, minus 4x, that is linear term which is written here, minus 4x. Minus 8, that is constant term which is written below that constant term, that is 2. Then we have to again subtract those terms from this polynomial. Therefore we have to change the signs of each term of that polynomial. Minus sign is there, therefore we have to write plus sign. Then see here, minus 4x plus 4x get cancelled, and here plus 2 plus 8, that is 10 is there. That means 0 plus 10 means 10 is there. Then here 10 is a constant term of which degree is 10 means here we can write 10x raised to 0. And here the degree of this is 0. But here the degree of that divisor, that is degree of x plus 2 is 1. That means here the remainder which having the degree less than the degree of divisor. Therefore we can't do the further division. Then we have to stop here, and here we get remainder 10, that is the remainder, and here we get quotient. Therefore here we have to write quotient, that is 2x minus 4, and here remainder is 10. Then we have to write the formula which is related with the division, that is here dividend is equals to divisor into quotient plus remainder. Then see here, we can put the values of those in this equation. Then here dividend is 2x square plus 0x plus 2 is equals to divisor is x plus 2 into quotient, that is here 2x minus 4 plus remainder is there, that is 10. Then see here that dividend is written in the standard form. Therefore 2x square, we have to avoid of writing that 0x term. Therefore 2x square plus 2 is equals to here x plus 2, which is multiplied by 2x minus 4 plus 10. Then we can tally the example by simplifying this here. Then we have to multiply, then get here x into 2x minus 4. Then see here x into 2x, that is 2x square. Then x into minus 4, that is minus 4x. Then plus sign is there, therefore plus 2 into 2x, that is 4x. Then plus 2 into minus 4, that is minus 8 is there. Plus 10. Then see here 2x square. Then minus 4x plus 4x 0. Therefore here minus 8, then plus 10 is there. Therefore simplifying, we get here 2x square. Therefore here we get 2x square. You can see here 2x square minus 8 plus 10. Minus 8 plus 10, that is here 2x square plus 2 is there. And here we get 2x square minus 8 plus 10, that is plus 2. Therefore here we get 2x square plus 2. Then here LHS is equals to RHS. Therefore that example is correct. And here we get the quotient and remainder. One of the example which is given here, that is x cube minus 64, which is divided by, that is x minus 4. Then first of all we have to write dividend in its index form. Let this dividend as a px, considered as polynomial in x variable. Therefore here the dividend x cube minus 64, which we have to write in its index form. Then see here 1x cube plus quadratic term is not there, therefore 0x square, plus linear term is also not there, therefore it is a 0x, minus 64x raised to 0. Then see here 3, 2, 1, 0. That is the descending order of the degrees of each term in the index form of that polynomial, which is given in dividend. Then that divisor, let this consider polynomial in x variable, that is qx, that is x minus 4. Then quotient and remainder we will get after the division of that polynomials. Then we have to solve this example using the same method which we have already solved the example of division of polynomial. Then first of all we have to write dividend in its index form, that is here 1x cube plus 0x square plus 0x, then minus 64. Minus 64 is there. Then that polynomial is divided by x minus 4. Then we have to divide that 1x cube, that first term of the dividend, by the first term of that divisor. Therefore here 1x. Then here we get 1x cube upon 1x, that is here 1x square. Therefore here we write 1x square in the quotient. Then we have to multiply that x minus 4 by 1x square. Then here we get 1x square into x, 1x cube minus that 4 into 1x square minus 4x square. Then we have to write those two terms below the like terms, that is 1x cube minus 4x square. Then see here, that is the cubic term and that is the quadratic term, which are like terms. Then we have to subtract that terms from this two terms of dividends. Then we have to change the signs of those both terms, that is plus sign is there, therefore minus sign is taken here. Minus sign is converted into plus sign. Therefore 1x cube minus 1x cube get cancelled. Here 0x square plus 4x square. 0x square plus 4x square. Therefore here we get 4x square. Therefore 4x square. Then we have to write the remaining terms from the dividend taken here, that is 0x minus 64. Again the first term of that dividend, that is 4x square, which is divided by 1x, that is the first term of divisor. Therefore here we get x square upon x, that is x, 4 upon 1, that is 4. Therefore here we get 4x, and that plus 4x, which is written in the quotient. Then we have to multiply x minus 4 by 4x, and therefore here we get 4x into x, 4x square minus 4x into minus 4 minus 16x. Therefore we have to write those terms below the like terms, that is 4x square below that 4x square minus 16x below that 0x. Then we have to subtract those terms. Therefore we have to change the signs of those terms, that is plus sign is taken here, and here 4x square minus 4x square get cancelled. Therefore 0x plus 16x, 0x plus 16x. Therefore here we get 16x. Therefore 16x minus 64. The remaining constant term is written here or taken here. Then see here, the degree of this polynomial is 1, and here degree of this divisor is 1. The degree are same, therefore we can do the further division. Then see here, the 16x, which is divided by 1x, and here we get 16. Therefore that 16 plus 16, which is written here, and here we have to multiply that x minus 4 by 16. Therefore see here, 16 into x, that is 16x, which is written here, that is the like term, and plus 16 into minus 4, therefore minus 64. That is, therefore here we have to change the signs of those two terms for the subtraction of those terms from these terms. Then minus sign is there, therefore plus sign is taken here, and therefore 16x minus 16x get cancelled, minus 64 plus 64, it is also get cancelled, and here the remainder is 0. Then see here, quotient, we get here 1x plus 4x plus 16, and here remainder we got, that is 0. Then we have to write the formula, that is dividend is equals to divisor into quotient plus remainder. Then putting the values of those, that dividend is x cube minus 64 is equals to divisor is x minus 4 into quotient, that is x square plus 4x plus 16 plus remainder is 0. Then we have to multiply those polynomials to check or to verify that the division which we have done is correct or wrong. Then first of all we have to multiply this polynomial by x. Therefore here x into x square, that is x cube. Then x into plus 4x, that is plus 4x square. Then x into plus 16, that is plus 16 is there. Again we have to multiply this bracket by minus 4. Minus 4 into x square, minus 4x square. Minus 4 into plus 4x, that is minus 16x. And minus 4 into 16, minus 64. Therefore here we get x cube minus 64. And here x cube plus 4x square minus 4x x square get cancelled, plus 16x is there, plus 16x minus 16x get cancelled, and here we get x cube minus 64. That is, here LHS is equals to RHS. Therefore, here that process of division is correct. Then see here, when remainder of any division of polynomial is 0, then divisor is a factor of dividend. That means here remainder is 0, therefore here x minus 4 is a factor of, it is a factor of that x cube minus 64. That means x minus 4 is a one of the factor of x cube minus 64. That is about the multiplication and division of polynomials. In next lecture, we will discuss about the new methods of divisions. Then, till you solve the remaining examples which is given in the question number 4 and question number 5 from practice set 3.2. Thank you.